Hey, Brian. Thanks for joining.
Hey, Anu. No problem. I made a couple of slides just to
That's
illustrate some
perfect.
points.
Perfect. We usually start at 3 minutes past the top of the hour, Brian. So,
Okay.
okay, we've gotten to 8:03. So let's get started. The meeting's recorded anyway for those who aren't able to come. Brian, do you know if anyone else from the link layer? I know Helia can't make it. Oh,
I don't know if other people are coming. I was hoping that Jeff and David would come as well, but
I just
Jeff is here. Yeah.
oh, hey Jeff.
Hey, how you doing, Brian?
Okay, so we've got Brian and Jeff, so possibly good time to get started. I don't see Cliff in the meeting. Jawad, is there any agenda items other than the link layer that we should discuss first?
No, I think if Cliff is not here, I can just say one thing, that there will be a regional activity in August in Taiwan, and just watch for the announcements if you would be interested in joining that or submitting a paper to it.
Thanks, Jawad. I think he mentioned it possibly last two times. It's in August, I think. And for the first time they're actually having they're planning to have stuff on the open chiplet economy. I guess bigger than we anticipated. So let's see what that program rolls out as. Okay, so let's get started. Today, as I listed on my agenda, we've as you all know, we've got an active link layer. They're releasing the control path spec along with the link layer 2.0 spec within the next few weeks is what I believe that the activity will happen. In the meantime, there's been some conversations of potential modifications or changes to the link layer. And the idea is to try to be agnostic to a lot of stuff that's below and provide the ability for a lot of stuff above the stack to have control. So before I say all the wrong things, I'm going to let Brian and Jeff take over.
Okie dokie. Thank you. So we had a discussion about this yesterday, and Jeff and David talked a little bit about their points on this. And so I made a couple of slides to kind of illustrate some of these points. So I'll put these up, and Jeff, please feel free to hop in at any time.
Sure. Yeah.
Okay, so, oh, is it? All right, it's not sharing. 1 second.
In the meantime, Cliff actually joined. Hey, Cliff, we were going to get started with our link layer and go in depth. Are there any announcements from the OCP you'd like to mention?
Just a reminder that the OCP EMEA Summit is coming towards us at the end of April, in case anyone would like to attend. The other important dates to watch for is the call for papers for the OCP APAC Summit, which will be August 5th and 6th in Taipei City. We'll open, I think it's April 1st, we will be issuing the call for papers. And we have formed a program committee for a full day of chiplet and advanced packaging discussions. And that's going to include Bill Chen from ASC. It's going to include Anawin Jawad, and I'm trying to remember who's the fourth person. I think it's Dr. Lowe from ITRI that will help us pull together and review the submissions and invite key speakers. We've already had some interest from folks, so anyone on this call that is thinking that you can make it to Taipei City in early August, please think about putting in a proposal to speak. We very much would like to have a strong representation from the OCP community around chiplets. I can tell you that in terms of sponsorships, the show is nearly sold out. And so we're expecting a pretty exciting event for our first event in Taipei City. And that'll be 2 days, as I said. So that's it for OCP APAC Summit. And I think that's it for the moment in terms of announcements.
Thanks, Cliff. Yeah, Jawad brought that up also, the issue summit. So it is the first time we're doing this, at least from the open chiplet economy point of view, right?
It's the first time OCP is doing a full 2-day standalone event that we're taking responsibility for. In the past, we've had some, call them 1-day, 1-day tech day workshops, full day workshops, and they were in Korea, but now we're going to a full OCP summit event, and this gives us a chance to have multiple OCP tracks. And given that we're in Taiwan, having a track on chiplets and advanced packaging makes a lot of sense with all the semiconductor people there.
Right. Yeah. Thanks, Cliff. Sorry, Brian, over to you now.
Okay. All right. Let me try sharing again. All right. Can you guys see that?
Yes. Surprisingly, we can.
Yeah. Zoom always gives me a little problem sometimes in the first time I started up each day. Anyway, hey, okay. So again, the discussion we had was the transaction link layer spec has a lot of benefits, especially compared to some other similar standards in the industry. The link layer spec that we have is a lot more focused on flexibility and SoC disaggregation, being able to pull a lot of the existing buses that you see in SoCs across die-to-die links and potentially do many across the same link, and being able to pivot in a way that is a little more cumbersome than some of the other standards. It's also easy for other people to add buses to the mix, and we have plenty of examples of how to get a wide variety of signals already across the link in terms of our profiles and bus variants. But right now the spec is very tied to BOW, especially in its language, and even though it has language where it kind of seems like a stack in principle, in if you're reading chapter headings and stuff like that, it's not really, especially the document and some of the way that it's built. It is more of a single element, I guess, than what it could be. So it's not as the individual parts of the transaction layer and the link layer are not as portable as they could be. And so we think that the overall spec with some modification could be used in other places with other types of die-to-die file layers or potentially other environments, and there could be a little more diversity in the ecosystem around the transaction link layer. So there it goes. So a proposal was put together. Again, this is Jeff's been driving this mostly, speaking for him here, and David, the primary original author, had shared a lot of views yesterday on the call, and so I'm going to try and summarize what I think are the key points of the proposal. I don't think the proposal right now is not a major effort. It is more of a tweaking, I would say, of the existing spec, because a lot of the things we had originally talked about in the link layer are already pretty agnostic and portable already. It is already pretty flexible, but the spec is written in such a way where it is like I said, very tied to BOW and not stack friendly, I guess is the best way I put it. So the first thing, I think that the first element of the proposal is rewording some of the terminology that we use in the document. We had some complaints about some of the things that we did. Some of the terminology being reused was potentially either confusing or could be reworded in a way where it makes everything a little more clear. So that was one thing, and then but the goal of rewording some things and reorganizing the spec was to make the entire transaction and link layer more PHY agnostic. But we don't think there, at least personally, I don't think that's a major overhaul. There's not really any functional changes to the spec itself. If you've already implemented the spec, I don't imagine any reason why it wouldn't be compatible with the second spec as well. It's just this is more of a specsmanship thing than anything, in my opinion. But the goal here is to, first level goal, near-term goal, would be to take that whole piece and be able to potentially move it around to other PHY layers. And the key example of this, and we've heard interest in the industry here of potentially being able to layer this on UCIe FDI. And so there is a little bit of a feature mismatch between those things. So the ability to select certain features in the link layer that are present or not, depending on whether you are directly on top of a PHY, or you're directly on top of a layer that handles part of that PHY negotiation and stuff like that, is important to make that distinction. And so that seems like an easy one, I think. And I think for most part there, again, that's not all. It's assuming we make text to the original document that draws a couple of lines and adds some language as to which components need to be present in which situations. I think that a mapping to something like UCIe FDI would really just be an appendix. And I think in the longer term, if we think that there's other die-to-die standards out there that make sense to work with and could make use of a SOC bus to packetization SOC bus packetization layer like the TLL. We could potentially, just add another appendix or another document that shows the similar mapping to those die-to-die layers as well. And again, I think at this point, it wouldn't be a major overhaul. So really, it's just like I said, just an appendix, not a full specification. And then longer term, I think that there could be quite a few things that could be done here. Right now, the spec is very useful, which is kind of the reason this has been proposed already. But it is somewhat hidden. It's just stuck on a GitHub basically at the moment, and I don't think it's really talked about a lot. And the other work that we did at the same time as the spec, so the profiles and bus variants and stuff like that. I don't know if they were ever officially published. They're just kind of in a directory right now. So there was a lot of work that is just kind of collecting dust, I think, at the moment. So I think there could be some work there getting the word out and getting eyes on these things to make these specs more reviewed and more useful. And it would be good to close any work that people think of that can close any work on bus variants or potentially add more and get more eyes on those ancillary specs as well to show how useful this transaction link layer is. In the even longer term, I think that I mentioned that right now we're looking at just some specmanship to make the authoring of things like the appendices for remapping the standard easier. Longer term, it would be good to potentially add some more stratification to the stack itself, and so that if people would like to make intermediate pieces in the ecosystem, that they're able to do so. Right now, it is just packet formats, but there's not like a clearly defined hardware interface or anything like that. Again, I think this one's a little more debatable whether you actually need something like that. We did make a intentional decision during the specs authoring to not do that. And that was so people could have a little more flexibility in how they implemented their controllers and the like. But I think there was some argument the other day that this actually kind of limits the spec in some way. So it would be good to have some scoping decisions in the link layer group and make and revisit those discussions and seeing if that's something that's limiting the ecosystem as it is right now, and whether new solutions to these problems could be enabled by us just adding, again, more clearly defined interfaces within these layers. Okay. Any questions?
Well, I guess maybe I'll make some statements as well. This transaction link layer specification, as well as the profiles and variants, they're in this GitHub. So from that standpoint, they've been published, they're publicly available. They were the foundation work, I think, on OCP ODSA when it was Open Domain Specific Acceleration Group. And it is tied pretty heavily to BOW. So as Brian was indicating, we would like to, talk about how you could actually target, different PHY layers. I think Brian was talking about there being, some disconnect there. And I think listened to the discussion yesterday, it seems to be like UCIe has this adaptation layer between FDI and RDI, where BOW would be more RDI-like and has some details in the link layer specification. So you can target FDI, no problem, but there are things that are in the specification today that wouldn't be required if you want to target FDI versus RDI. And then I would just say also these profiles and variants, just to kind of get a better idea what that is these are mappings of AMBA protocols onto the transaction and link layer. So they're just specifications that talk about how you map that into the stream that you're building with this transaction and link layer.
And Jeff, that's based on the bit stream. That's based on an RDI type bit stream, right?
Yeah, the output of the transaction link layer is a bit stream that goes into, a PHY, a BOW PHY, can be directed to a UCIe FDI layer, maybe even an RDI layer. Yeah, and above that though, these profiles and bus variants, these are different AMBER protocols like CHI or AXI. We've mapped out a group, and Brian was very active in this group as well, mapping out how you would take these AMBER protocols and map them into the transaction.
Yeah, we never really got to it, but there's a bunch of other buses that could be that we could eventually make some bus variants on. I think we were kind of hoping other people would step forward and say, "Oh, I really need tile link. Can I, this is what I came up with tile link," and then we would be publishing those. But I haven't seen a lot of community engagement quite yet on other buses out there. But that was the goal, to try and get a ecosystem started around people showing bus mapping flavors and the like.
Right. So you're saying that even if somebody used a UCIe PHY for the nuts and bolts of physical connectivity, if we incorporate this mapping, they could actually use this link layer, the same link layer, but map the bits as needed differently as per the UCIe. Okay.
Yeah.
So I think that's a big the UCIe made a specific decision, coming from the places they were coming from to develop an accelerator focused ecosystem, right? So it's a lot of PCIe and CXL and things like that. And there's been a number of people that have written bus mappings to their streaming interfaces, right? So, and you'll see a number of people doing proprietary things, and ARM has done a Chai C2C mapping basically on top of the streaming interface and things like that, right? But these are all very targeted engagements against that, and there's not a lot of, except for I guess some of the things that ARM's published, there's not a lot of industry standardization around really just doing full SOC disaggregation the way that most people think of SOCs. So if you at the moment, if you're using UCIe, if that's all you have UCIe PHY layer, and you would like to carve out a subsystem in your SOC and move it to another die, then your two options are re-architect that subsystem so that it is basically a PCIe accelerator, or use some sort of vendor specific mapping of your buses onto UCIe streaming. Where our transaction and link layer does 90% of that effort for you already, in terms of specmanship. Somebody could implement RSpec and then as we're proposing here, have a mapping to one of the UCIe interfaces, and you have that you have those bus connections for you already.
Oh, I see. Okay. The UCIe also does a lot of the manageability and security piece. Is that done in their D2D adapter layer between the RDI and FDI?
Yes, I think from
You
what
can
I've
do it
seen,
over sideband too, I think.
sideband, yeah.
I mean, they're all MCTP. Sorry, yeah, is that right? I'm using the wrong acronym. You know, the manageability standard from DMTF or whatever. And so it's just a different packetization for a lot of their management stuff over, and then you can remap that over their main band or sideband, I believe.
Okay.
So in fact, that the way that they've done their manageability stuff is, I mean, if you're talking about, again, beyond just the PHY stuff, because their PHY stuff's obviously just over the sideband. If you want their greater SOC manageability stuff, that can be mapped onto other things as well. You could technically map that onto our
I see.
BOW main band sideband as well.
Okay. Yeah. I think
Yeah.
having flexibility is good.
Yeah, my comment was that, yeah, all of this communication happens over sideband, but you know, where it takes action is in this adaptation down into the PHY layer. The link layer is not really affected by a lot of the manageability aspect.
Okay.
Right. Yeah. Yeah. I agree with that. And in fact, you know, for a lot of SOCs, they want to do their, especially if getting back to the original point for disaggregation, if you're already cutting some systems up, you already have solutions for SOC management, for reading temperature sensors, or for uploading firmware and stuff like that. And those things are going to be based on, you know, if you're in the ARM ecosystem, you know, a whole bunch of AMBA buses. You might have AXI stream buses, you may have AXI4 buses, you may have Chai, whatever, right? And so you already have solutions for all of those bits. If you have a way of just getting those signals across the link, then, you know, you don't need a lot of other uplift in terms of the rest of your management protocols and the like, right? You don't need to re-implement all of that stuff with a whole bunch of additional microcontrollers. You can just use the buses.
I see. Okay, that definitely does simplify it, right?
Mm-hmm. Yeah, yeah. Again, depending on what your goal is when you're integrating the chiplet, yeah.
So then I have a question for Durgesh. I know you guys are using the UCIe as the actual nuts and bolts of the PHY connectivity. Will something like this work for you if the link layer, I don't know, you might have already developed your own stuff, but if it was independent of what was sitting underneath, is this something that could help you guys?
That's what I believe, Anu, that it should help. I'll just try to get more information. Whatever was presented appears very helpful.
Okay, no, that is good to hear. And then Durgesh, the other question I had for you was from the system, chiplet system workstream that we are working on, putting the agenda and focus areas together. That does tie in to some extent with this, right? I mean, all the layers tie in a manner of speaking, because they send bits or some kind of control bits up and down. I just want to make sure that all of that is put in perspective when we talk about it. Itai was looking at the link layer and had a lot of questions. But I want to make sure that any change in scope or additional features that Ryan and Jeff are looking to add also makes sense with what you guys are planning to do with the system. Like, it all ties together nicely.
I'm not
Yeah,
sure.
sounds good, Anu.
I'm not sure it does, right? Because the most important part of this slide deck was it's designed to disaggregate an SOC, right? There's a whole bunch of people trying to figure out, I've got chiplets, right, from 2, 3, 4 vendors, and how are they going to hook up together and talk to each other and be secure and be manageable and so on, right? So I think that's the bit that is kind of missing, right? And you keep mentioning FDI, but if you actually talk to the Synopsys people, and they say 90% of the people that are using UCIe are using either streaming or raw mode, right? So I've felt for a long time there's a complete disconnect with what the link layer guys are doing and what people trying to build chiplets as reusable chiplets, right, are trying to do. So I think there's a disconnect and that needs to be addressed.
You do need something on top of the link layer, and from a standards perspective. So the link layer was really always meant to provide a way of mapping SOC buses across the link. And in fact, we don't make hard decisions on exactly those bits. The profiles and variants are meant to be how to say, they're meant to be mutable, right? They're meant to be you use these and as a language for talking to people, saying I used this bus variant, right? And then if you decide that you would like to make different decisions there, you can use a different bus variant. And so the whole point of this, and I feel this is kind of the same way with many of the ODSA specs and BOW, and we're talking about the control path and everything. It's never meant to be, here's a hard stamp on plug and play chiplets. It's more like, here is a language so that we can talk about how to put these things together. It was always meant to be more of a stepping stone than a hard stake in the sand. So I think it is, if you want to say, here's my plug and play chiplet, there's a whole lot of other work that has to be done to actually make that happen. And I think that the current link layer spec, and again, that can be improved with some of these changes, give you a framework in which you can build such a thing. Whereas, without this link layer, then your conversation starts at ground one, right? So at this point, you are already starting 3/4 of the way where you could define such a thing with a much smaller spec if you wanted.
Yeah. No, I get that. All I'm saying is that there, people, I'm just trying to get to the brass tacks to a certain extent, right? Which is that there needs to be, there needs to be some hard decisions made, right? Because, or at least a pathway to saying, hey, here's at least one way that you could do this. And I think there's a lot of frustration that a lot of people have with a spec and an ecosystem which says you can do anything you want, right? And there's a lot of, if you're trying to do the highest possible performance, right, that's the way you want to go. And I get that, right? You're going to customize everything. But there's a second world where you want to be able to, reliably bolt onto something. And so you need to have some mechanism of, who am I? Where am I? What am I supposed to do? There's a whole bunch, as you said, there's a whole bunch of stuff that can be added on top, and some things that need to be fixed in some way, even if it was, hey, here's a GitHub with, let's call it standard version 1, right? And at least if you do this, you'll get something that works and something that people can use, right? So a lot of people, I think, don't have huge staff that are trying to implement this right from T0. Does that make sense? I mean, it's just like, okay, how do I get started? And what can I do to build a chiplet that will be usable by a bunch of other people, right? So those are some of the things that I think we need to address somehow.
Yeah, I think if you put the manageability aside just for a minute and you just kind of look at the main band and, interoperability between chiplets, when you're talking about a disaggregation model where you're taking an SoC and disaggregating into chiplets, what has been specified is really kind of, there had to be alignment on the, let's say, AMBA protocols that you're using for the SoC integration. And that still, is something you have to do when you disaggregate into chiplets. Now, I mean, we could work on, these profiles and bus variants and say, here are some standards, some hard standards of how you would interface at an AMBA level, right? And that could be a way that you kind of get to.
But how do we get to aggregation of chiplets? How do we enable that, right? That's a different, it's a different mentality than we're going to disaggregate an SoC design.
I mean,
So
you have to, yeah, go ahead, Brian.
Well, like I said, if you're taking a subsystem, an SoC, right, and you're putting it in another chiplet, you're drawing a custom perimeter for that. Only thing that you really need to do, there's two things you need to do here in order to make a standardized subsystem would be to first, draw a perimeter that you think that other people would also use, right? And so in terms of the buses and the signals that we need to cross that, right? And then and that gets you most of the way here in terms of the link layer from what we have, right? So we already have, as Jeff mentioned, these profiles and bus variants and things like that. And that was in many cases our first stab at what we think would be useful buses for such a profile, such a perimeter. So in terms of the transaction link layer, a standardized plug and play perimeter would just be a list of these things, right? You need a 256-bit AXI bus that from this bus variant, you need a AXI stream if you're, for if we're going to go down the ARM friendly path here and for MMU communication, whatever the case may be, right? And you make this list of buses, you make this list of features that have to go across these links, right? And then at least from the transaction and link layer spec, you've got your standardized chiplet. I don't think anybody, especially in the group when we were authoring this, wanted to make that call for everyone because there's a lot of ways of doing these things, and that we all had our own little priorities in how these buses were being put together and how we think of a subsystem in an SoC. But that said, it doesn't mean you can't do that. You definitely can make a perimeter that other people could conform to. But even if you have that, I think the point is I don't think that's even the full story from the rest of the plugin ecosystem point of view. There's probably another dozen things you have to specify on top of these things in order to make sure that everything behaves friendly when you actually do plug it together.
Yeah, I think we need to get to that path, right? So we have to start. I think that's the challenge.
So Brian and Jeff, I have a question along the same lines. So it's really exciting to see that you guys are thinking about supporting other PHYs as well, making it a little bit more generic. So one big problem commercially is for open chiplet economy to be successful, that somehow industry needs to be able to validate that these chiplets interoperate with each other. And there's no easy solution. So while you're talking about maybe defining some things on top of it, do you think it is conceivable that we write some kind of we specify some kind of a interoperability method that we can include or just put on top?
For the link layer itself, or are you talking about actual chiplet to chiplet connections?
No, I'm just talking about specification of maybe some add-on things on top of the link layer. And this is just a brainstorm question. I don't know the exact answer.
You could specify test cases on top of the link layer, I guess, if that's what you're saying. This seems like a much broader question than I think I have the capability of answering inside this kind of meeting.
I mean, right now, I think the profiles and bus variances, I would view it maybe as a framework that, we took some examples of how you would map, certain AMBA protocols onto the transaction layer. And I think if we kind of worked on those specifications and had a broader audience working on them, then you could potentially come up with ways in which there's more interoperability in those specifications, and that they would address the needs of a lot of chiplet vendors, right, that want to participate in the marketplace. And I don't know if we could get to a point of you have, electronic specification of that, and you could somehow also have, some kind of generation where if there is a disconnect there, that you generate some code that would resolve that. And then those chiplets could be interoperable, if that makes sense.
Yeah, I think there are additional behaviors on top of the AMBA buses you'd have to talk about as well. Like our focus is mostly just getting signals across the link, but we don't really talk about what those signals mean. And if you're actually doing plug and play from an AMBA level, you do have to talk more about what the behavior is of some of those things. And to the point on testability, I think the best thing you could do is you could possibly write some standardized tests on top of these things, just streams of read-write transactions and expectations. But that implies a framework that I think. So I don't know. There should the testability stack that you would need in order to actually determine if these two things can talk to each other correctly is so. I think it's a very deep problem, and but I think carving out a small piece of that here is definitely possible. You could do some testing, I think, in terms of either defining a specific test or just defining some test criteria. But if you look at what some of the other chiplet standards have proposed, there's a lot of they're a lot more physical oriented with some of these things, and I'm not sure where the problems would all align in trying to do this, whether it is really at the transaction link layer or whether it is more holistic stack discussion. UCIe golden dies and also all those kinds of things that are done in other places, right? Where you have something you can actually package against and test your system, or actual logic on the shelf that you can go stick in an FPGA and test. I think those are broader ecosystem questions that probably need to be solved at a higher level than necessarily just the transaction link layer.
That's great. I think we're on the same page. This is a pretty big problem that needs collective thinking. So historically, if you look at the PlugFest interop for UCIe USB, they would test the PHY and the link and transaction and applications, all of that. And maybe in different electrical configurations too. Bringing something like that together for chiplets is very difficult. So you know, if you can do anything at the link layer piece for it, I think it'd be worth thinking through that a little bit, in my opinion.
I just like to throw in, we're looking at some of this stuff as in the Open Atomic Ethernet work group for like, you know, message passing around networks. You know, so this level of stuff with the SerDes is kind of a lower level thing. The Atomic Ethernet problem is just like a general communication problem. But you know, the two are you know, tied together somehow.
I might add a few things to what Jawad said. For those of you who may not know, but once the first version of the link layer was done, I actually talked with Boppy, who was the OCE project lead at the time. And the first thing I said, is there any way to make this more of a universal link layer? Because then I felt that the impact of the OCP as a project in chiplets could be much bigger if this could straddle more than one PHY. So I'm very happy to hear this kind of discussion going on in this group, and I'm hopeful that the community decides to pursue this. I think it could have significant impact if done well, and might take several iterations to get to a broader picture. The other thing I would say is, if we do go ahead and do this, we would definitely be able to do things today that we didn't have when the first link layer spec was released, around leveraging the OCP open chiplet economy on the OCP marketplace to make this visible in the world. Also, as a follow-on to the spec, we could create some training courses that would then live on OCP Academy, which is launching this year. So that would be another way for people to get trained on the spec, and hopefully we could have some use case examples to show. Again, that would make sure that it doesn't sit in a GitHub somewhere with only a few people using it.
Sounds good.
Do I have any network and chip folk here?
I'm not sure what you're looking for, Kevin.
Well, I was looking for, you know, this is a particular kind of communication you're doing here. I've worked on network and chip stuff, and generally what happens there is you got blocks of IP that have different interfaces. So basically the chiplets, you're kind of coming down from board level and up from network and chip level, and you're trying to, you want to kind of mix the network and chip approach to things with the board level stuff. So you got you got an extra level of complexity, and one of the things we're looking at, the atomic Ethernet thing, part of what we're trying to do there is capture how reliable transport is, and then factor in the reliability and how we synthesize networks. You know, more looking at software-defined networking.
Right, yeah, you're talking more the sort of really the NOC and networking space, yeah.
Yeah, I mean, if you do something like UCIe or bunch of wires, whatever, there's, you know, error rates on that stuff, and depending on how you use it. So we're sort of trying to tease out what the software requirements are for how a link works, and then factor that into how you configure things.
So I think what we're hearing overall is that this is going to be pretty useful to everyone. I think we need to mute someone in this, yeah. So Brian and Jeff, going back to the link layer team, I'm guessing that everyone on that team is in general agreement with what you shared with us today as proposed next steps I know you've got the short term and the long term.
Yeah, I think at short term, again, the goal here would be to, add some terminology to the spec, and then add an appendix specifically for UCIe. Again, I put FDI on here. I think that's probably the most useful, but there could be some discussion around doing RDI as well. But either way, I think, again, that would be just another appendix. And then in longer term, I think there's probably better stratification we can put into the spec itself in order to give, depending on what people want in terms of flexibility. And obviously, in a longer term, as mentioned, we can have additional discussion around the existing bus variants, or adding more of them, or again, I think there was some discussion about changing the name. Specifically, the bus variant name is potentially a little confusing. So maybe clarifying some of that terminology there. To the other points that have been raised on the call, I think the group would be perfectly happy to have discussions around standardizing more of that perimeter if needed. Though I think that might actually be more of a that might be a wider group thing. If you're actually going to be standardizing full chiplet perimeters, exactly what's going into these things in terms of all the buses and stuff, that might be a wider conversation than just the link layer. But definitely getting these pieces together, I think, is what the current proposal is.
Yeah.
So,
this is Kevin. Yeah, I
Kevin.
wanted just to add on to Brian's comments. So, well, two things. So first, UCI, because it stops at FDI and there's a big gap to the NOC, something like this could really be very valuable to the whole industry, to Cliff's earlier point. So I really like the idea of trying to do that. But because the way OCP is organized with test is one work stream and link layer is another and PHI is another where I play. What Kosh is talking about, I agree that our flexibility is both a benefit and a hindrance, but if we want to write something that's, let's just say, an example use case that cuts across all of them very, for a specific application or a specific use case, that isn't really easy to do in the work streams as they're organized now, because they're all, so independent and so narrow. So that's something for you to think about, how to cut across them to do what Kosh is talking about, to create like in a specific implementation example.
Okay, so that's really interesting, Kevin, because I was just going to go back to Kash saying, would a specific example help you? And that particular example may not be exactly how you plan to implement it, but it's sort of a means to an end. You know how it's done, and you can then modify it to work for the bus or the bitstream, whatever you choose to do. Is that what would help you, Kash, given all this flexibility is being a bit of a pain in the neck for you?
Yeah, well, I think what we'll need to do is perhaps look at some real world applications, right? And then say, okay, somebody's trying to build chiplets around this. I think it was Brian or Jeff mentioned that, UCIe was really designed as a PCIe, right? That's the genesis of UCIe. And it struggles with memory and Ethernet and some other, common protocols, right? And then just generally sending data. So, and that's one of the reasons why people like Bo, although Bo has lost the marketing war, but that's a different subject. But I think that the fact that they're looking at, applying this to UCIe, I think makes a tremendous amount of sense. I definitely applaud that. And then you get to which UCIe are we talking about, right? So UCIe 3D is very different than UCIe 1.0, and so on. And the other part I think Kevin mentioned was you know, we need to have some NOC people in here, because when you've got multiple chiplets, how do you address the ports? How many ports do you have? I mean, it's a big issue that I think the whole industry has. So I think we'll have to define certain use cases and at least let people say, if you're, let's say you're in a microcontroller, let's just say you're in an edge AI kind of application where a lot of sensors and so on are coming in. Here's one sort of way to do it. You may not have 20 UCIe ports, right? So you know, you may be putting a lot of different types of data through one or two ports. And one of the challenges here is the people who wrote all these specs are big iron people, right? Doing big CPUs and big accelerators and so on. So it's going to be challenging. I mean, there's no question this whole thing is very challenging, like, because you want to know how things come up, where are you going to get your control, and you know, are you secure? I mean, there's as Brian said, there's just a whole lot of system level other stuff that also needs to be looked at. And so we have the hype machine, which is, you know, chiplets are everywhere and they're going to be everywhere. And then we've got the real world, which is, how do I get two chiplets to talk to each other once they're manufactured, right? So I think that this is going to take more discussion than obviously what we have right now. But at least we're starting to talk about it, which I think is a good thing.
Right. Yeah. No, I think this is a good step in the right direction. I just noticed that Itai is here. Hi, Itai. I wasn't sure how much of this discussion you had heard, but I think you have access to the link layer spec and the control path spec, and now the goal is to do a little bit more than already has been done in the direction of what industry wants.
Yes, okay, yeah. I think it's a good direction that we are talking about here. Yeah, I wasn't able to connect at the beginning of the meeting. Yes, again, the idea is that eventually the key element for the market is that two chiplets can talk to each other. And that's, I think, the main goal at this point. This is how we see it.
Yep, thank you. Any other questions for Brian and Jeff?
Hey, Brian, you didn't include a link to the new link layer spec or the bus variants that you're working on. You could drop that in the chat or
I mean, there's
someplace
the link layer hasn't changed since we published it, so it's not the only thing we've been working on since the link layer's been published would be the sideband stuff, and that stuff's almost done, ready for review. Well, it needs to be reintegrated. It needs to be reintegrated into the actual link layer spec. But in terms of as a separate spec, it's pretty much the initial version's done. But there's not been a change. So whatever you get out of the GitHub right now in terms of both bus variants and the link layer spec is the current version.
And I just dropped the link in.
Thanks, Jeff.
Thanks, Jeff. So Brian, so this was really fantastic. I really appreciate it. I know we talked, I think it was yesterday or the day before, and then I requested that you join this meeting today and share the thoughts. And it's great to see everybody's on the same page. We're all going to face the same problem sooner than later. And this seems to be a way to get there in bits and pieces. I agree the problem is bigger, but I think this is positive steps in the right direction. So I guess next steps are within your link layer team, and then writing up a bit of a scope document for what you'd like to do. Would that be correct?
Yeah, definitely a scope discussion would be good. It would be good to get additional participation on the link layer team. You know, it'd be would definitely the current attendance is fairly focused on the sideband stuff that we've been doing as of late, and it would be good to get more back to the more attendance back to the main band. Yeah, so I think yes, the first discussion would be scope and talking about some of the things that I mentioned today.
Yeah, so that is a call to everyone on this meeting and anyone you know who's interested. if we want the scope to do what we want it to do, it's important to at least participate as best as we can. I understand everyone's got a day job too, to make sure it goes in the right direction. So for all of those who'd like to see something come out of this or are interested, those meetings are on Thursday at 8 Pacific. Would that be correct, Brian?
Yeah, it's 8:30, I think, which is kind of a weird time. I was actually gonna suggest to Alia that we realign it a little bit, but yes.
Okay, so currently it's 8:30 Thursday Pacific AM, but it could be realigned, and we'll put that on the wiki if things change. So thanks, Brian and Jeff, really appreciate it, and yeah, steps in the right direction. Thank you, everyone. Have a wonderful weekend.
Thank you.
Thank you.
Thanks. Bye.
Bye-bye.